Hi, in this video, we'll be continuing the H2 Mathematics 2018 paper 1. So for question 7, they give you an equation which is x squared minus 4y squared over x squared plus xy squared equals to half. And we want to show that the dy dx is this expression. So the natural way is to just differentiate this, and you can either use the quotient or rule or power rule. But what I would like to do is I cross multiply this first so that it becomes one line expression, so I don't need to use any quotient rule, which makes it easier and nicer to solve. Then from now I will just differentiate normally, so I'll get 4x minus 16 dy dx equals to 2x plus y squared plus 2xy dy dx. Then because I want to make dy dx in terms of x and y, so I need to bring all the dy dx to one side, and then I'll get 2xy plus 16y dy dx. And then I'll bring everything else to the other side, which will give me 2x minus y squared. Then I will just dy dx equals to 2x minus y squared over 2xy plus 16y, which is the expression I'm supposed to show. So you can see how it's much easier instead of using quotient rule and simplifying it. Instead, you just cross multiply, you have one line, and then you don't need to do all these formulas. For part 2, now we know that the points P and Q each have coordinate 1, and the tangents meet at point N, and we're supposed to find the exact coordinate of point N. So again, now because we know both are 1, so we just let x equals to 1. Then this part must equals to 1, so it's 1 minus 4y squared over 1 plus y squared equals to half. Then we cross multiply to get 2 minus 8y squared equals to 1 plus y squared. This gives us that y equals to plus minus 1/3. So P is either 1 and minus 1/3, and Q is 1 and 1/3. Then we find the gradient at P, which is minus 17 over 54. This allows us to find the equation of tangent at P, which is y plus 1/3 equals to minus 17 over 54, whole thing times 1 minus 1. And this gives us equation 1, which is minus 17 over 54x minus 1 over 54. Similarly, at Q, we also need to find the gradient, which we just sub in and solve, which gives us 17 over 54. And thus the equation of the tangent, again using the y minus y1 equals to m bracket x minus x1 formula, we'll get y equals to 17 over 54x plus 1 over 54. And thus, when these two lines meet, they must equal to each other. So when you equate them, you see that 17 over 54x plus 1 over 54 equals to minus 17 over 54x plus 1 over 54. Then you bring this over, bring the other one over, it will just be 17 over, then you can simplify 17 over 27x equals to minus 1 over 27, because 2 times 1 over 54 equals to 1 over 27. And this allows us to find x to be minus 1 over 17. And we already know, then we just sub in 1 over 17 into here, minus 1 over 17 into here, into either equation 1 or 2, and we get that y equals to 0. So this tells us that the exact coordinate of n equals to minus 1 over 17, comma 0. Next, for question 8, we are given a sequence, and for the first one, they tell you that un plus 1 equals to 2un plus a times n, where a is a constant. So given that u1 is 5 and u2 is 15, we're supposed to find a and u3. So we just need to write what is un plus 1 equals to 2un plus an. So u2 must equals to 2u1 plus a times 1. This tells us that 15 equals to 10 plus a. So a would then equals to 5. So by knowing a is 5, we can just find u3 because u3 will just equals to 2u at 2 plus a times 2, but a we know is 5, so it's just 5 times 2 plus 30, which gives us 40. Now it is known that the nth term of this sequence is given by this formula, and we also find a, b, and c. Well, because there's 3 unknowns, we can just use the 3 terms that we find, u1, u2, and u3. So this gives us that the first equation gives us, we sub 1 first, then you get 2a plus b equals to plus c equals to 5. Then we sub 2, which gives us 4a plus 2b plus c equals to 15. And then we sub 3, which is 8a plus 3b plus c equals to 40. And using our GC, we are able to find a, b, and c. So a is 7.5, b is -5, and c is -5. As for part 3, we need to find the sum of ur in terms of n. And so how do you find the sum? Okay, so we do the sum of un and ur, and we know what ur. Ur is 7.5 ur 2 to the power r minus 5r minus 5. Okay, so with that, we take this out 7.5. So what? Okay, so what is the sum of 2 to the power n? Well, that's just 2 plus 2 squared plus all the way plus 2 to the power n. And we realize this is actually a geometric series. So it's just 2, the first term, times 2 times 2 to the power n, because that's the number of terms, common ratio to power number of terms, minus 1 over ratio minus 1. So that's this, and this simplifies to 15 to n. As for the next part, okay, so the next part is actually minus 5 sum of r. What's the sum of r? 1 plus 2 plus all the way to n. And this is actually an arithmetic progression. So in that case, now you do the arithmetic progression formula, which is number of terms over 2 bracket first term plus last term, which is 1 plus n. So it's n over 2 times 1 plus n. Then the last part is a constant, so it's just like -5, 1, -5, -5, all the way to -5 n times. So it's -5n times n. So simplifying this polynomial, you'll get -5 over 2n squared minus 15 over n minus 15. So the sum, when you add all this up, it will be 15 times 2 to the power n minus 5 over 2n squared minus 15 over 2n minus 15. So I hope it's clear. If you have any questions, please leave it in the comments. Like I always say, I will answer them. Now for question 9. A curve C has a parametric equation x equals to 2 theta minus sine 2 theta and y equals to 2 sine squared theta. So we are supposed to show that the dy dx equals to cotangent theta. So in this case, we just need to differentiate with respect to theta for x and y first. And when you differentiate with respect to theta, you get 2 minus 2 cosine 2 theta for dx d theta and 4 sine theta cosine theta for dy d theta, which is also equal to 2 sine 2 theta. But we shall leave it in this form and we'll see why. So we get that dy dx is actually dy dx d theta times d theta dx, and d theta dx is like 1 over dx d theta. So it's actually dy dx d theta over dx d theta. That's why it's like this. So in that case, the y d is what? 4 sine theta cosine theta, and the x d theta is 2 minus 2 cosine 2 theta. So we can use the double angle formula, which is the trick that you must remember whenever you want to simplify, get rid of this, because this is like, okay, so when you use the double angle, you see that you have 1 here, and this minus 2 will cancel this 2. So what you're left with is minus 2 times minus 2 sine squared theta, which is 4 sine squared theta. And the numerator is 4 sine cosine theta, This force cancel out, this sine cancel out, this power cancel out. So it's cosine theta over sine theta, which is cotangent theta, which is what you want to show. Next, they tell you that the normal of the curve at alpha meets the x-axis at point A, and we're supposed to show that x is actually just k alpha. So how do we do this? Well, we know that the gradient of the tangent at alpha will be just cotangent alpha. This tells us that the gradient of the normal is minus tangent alpha, because it's minus 1 over cotangent alpha, which equals to minus tangent alpha. Okay, so this part is clear. Then we supposed to find okay, so naturally you just need to find the equation on the normal and then find the x coordinate. So we find the equation on the normal at this point. So you just sub in what's the y. The y coordinate is 2 sine squared alpha. So 1 minus 2 sine squared alpha equals to minus tangent alpha bracket x minus 2 alpha minus sine 2 alpha, because this is the x1, so x minus x1. So okay, then you just, because you know this line touches, you want to find the x coordinate, which is the where it meets the x-axis. So the x-axis means y is 0, so you just sub y is 0 first. So you can why we do that first is to get rid of terms that we don't need. So we don't need this y. So we get this part. So you got the minus 2 sine squared theta equals to minus tangent alpha bracket x minus this. So then we divide the minus tangent alpha over, and this gives us minus 2 sine squared alpha over minus tangent alpha equals to x minus 2 alpha plus sine 2 alpha. Okay, so what is this now? Okay, if you just see, the minus sign will cancel out. Then you got 2, then you got sine squared alpha over sine alpha over cosine alpha. What this power will cancel this out. This cosine will flip to the top because it's like divide. So that gives us actually 2 sine alpha cosine alpha, which is over here. Then you bring this 2 alpha over, you bring the sine 2 alpha over. Then you actually see that this cosine 2 cosine alpha sine alpha, which is actually just sine 2 alpha, will minus away this minus 2 sine alpha. So this part's cancel out, which will leave us with this. So x equals to 2 alpha. Then this shows, because it is just a constant times alpha. So k is 2 in this case. For the last part, it seems complicated because they give you this whole story that you read. So one thing to note is that in the A-level exam, they give you a lot of story, a lot of like information that is not really needed if you understand the theory behind the mathematics. And so what they want you to just do is use this formula is to find the arc length of any curve. Arc length means it's the length of the curve. So, and then they tell you do it in parametric form where your theta runs through beta to gamma. So now they just want to find the total length of C. So we know C runs through 0 to theta. So this beta is 0 and this gamma is pi. Then we just use the formula. So it's just applying formulas. That's one thing A-level trains you to do, which is to learn formulas fast so you can apply them. And so we just use the formula naturally and it just flows intuitively. So you just integrate from 0 to pi, you square root dx d theta squared plus dy d theta squared, and we already found what's dx d theta, which is 2 minus 2 cosine 2 theta, and dy d theta is 2 sine 2 theta. When you square it, it's just 4 minus 8 cosine 2 theta plus 4 cosine squared 2 theta plus 4 sine squared 2 theta. This part is 4 bracket cosine squared 2 theta plus sine squared 2 theta. It doesn't matter what the angle is, this formula will always be 1. So this tells us that this whole part is just 4. So this 4 and this 4 add together, which gives us 8. Then we just minus 8 cosine 2 theta. And again, using the trick that we want to get rid of the constant. So we double angle this using the 1 minus 2 sine squared theta. So then this 8 will cancel out. And this gives us with square root 16 sine squared theta. So this allows us to square root nicely because sine theta is bounded between 0 and pi, which tells us that sine theta is always positive. So we just get 4 sine theta. So this integrate of 0 to pi, the 4 sine theta of d theta, and integrating 4 sine theta is easy. It will just be minus 4 cosine theta, and then you just sub in at pi, evaluate at pi minus evaluate at 0. So it's minus 4 bracket minus 1. Then the minus 4 is just plus 4 bracket cosine 0 is 1. Now this is just 4 and this is 4, so together they are 8. And that's the answer. So you can see that is fairly simple. You just need to know that the story is just misleading you if you read too much into it. Don't even need to care, just use the formula. So that's all for this video. I hope you have enjoyed it. I'll finish up the paper in the next video. So see you again. Bye.